Muy bien, buenas tardes.
Good afternoon. I'm going to be talking about Philosticta citricarpa or Gignadia citricarpa, which is the causative agent of citrus black spot, which is a pathogen which is not yet in Europe. We've seen the previous presentations, we've seen pathogens that are present or have been recently detected. But in this case, we're talking about the pathogen, I'm going to say the causative agent of citrus black spot. And as I said, it's not present yet in the European Union. As we heard earlier, it's one of the pathogens that's on the list of these harmful organisms of Directive 2029 EC. It is included, Philosticta citricarpa, as a harmful organism whose introduction and propagation should be prohibited in all member states if it is presented in certain vegetables or plants, or plant products. And so that refers to plants and fruits, not seeds. Seeds are exempt from regulation here because it's not a seed-borne pathogen or fungus. It's a complex fungus, ascomycete, which has two different types of reproduction. It has asexual reproduction and sexual reproduction. And you can see that better in the next slide, where I show the cycle of the pathogen. In sexual reproduction, it receives the name of Gignardia citricarpa, and it has specialist structures, pseudotecias, which develop in leaves fallen onto the orchard floor, and ascospores, which, as I said, are the main way that the disease is spread. The fungus also has asexual reproduction in fruits and shoots, and in this case it reproduces in conidia. This slide shows the cycle of the pathogen, and I want to mention a few of these specific topics with regard to inspection. As you can see in leaves fallen on the orchard floor, we're in the center of the cycle there, and this is when we have this pseudothethia, the sexual production of the fungus, and inside they produce ascospores, which are disseminated by the air and which comprise the primary inoculum for infections and for the dissemination over long distances of the fungus. In infected fruits, the fungus develops very slowly. The incubation period in fruits is very slow, and it can go on for over 2 months. That means that we can have infected fruits without showing any sign of the disease until at least 2 months later. And then these fruits have lesions on them, and which will appear on pycnidia on fruiting bodies, and lesions which form secondary inoculum, and these can also appear on fruits and shoots. All of these are infections caused by ascospores or conidia, and all of these give rise to symptoms that we can see on fruits and on leaves, although obviously the most important are the symptoms on the fruit. This photo shows the first symptom of the disease, marks or spots that are very clear, depressed necrotic lesions from which the disease takes its name, citrus black spot, and which cause very significant damage because they basically mean the commercial loss of the fruit. They're hitting the fruit where it most hurts, if you like, which prevents the fruit being sold if they are destined for fresh fruit sales. You can see sometimes on these spots when you have a mature lesion, when the fungus has had all the time to develop the infection, you can see the pycnidia, which are visible either with an instrument for seeing them or just to the naked eye. And this is where you have asexual reproduction of the ascospores. So this is a pathogen, as I've said, is not present in the European Union. And I thought perhaps this presentation would be more interesting if I talked about something that wasn't present, and to really talk about the challenge of phytosanitary inspection. We heard just now about inspection on citrus fruits, ornamental plants, which has perhaps been somewhat lacking and has not been able to prevent the entrance of X. fastidiosa. Now, this is a challenge also in Philosticta citricarpa. In Mediterranean conditions, it could be a significant pathogen. In the case of Spain, as Emilia Montesinos mentioned in the introduction, the laboratory that's in charge of inspection of suspected samples with quarantine funguses is the Polytechnic University of Valencia laboratory. And as head of that laboratory, I wanted to discuss with you the challenges of this ongoing work of phytosanitary inspection to prevent this pathogen entering. Firstly, equipment. A laboratory that manages quarantine fungi has to have the right equipment to do so in biological safety. And to that end, we have a white room of biological containment, and all inspection of quarantine organisms, including citrus fruits. When we receive samples of citrus fruits, we inspect them in that room under very controlled conditions of biological safety. We inspect oranges, limes, lemons, tangerines. And the first thing to do is carry out a visual inspection, which complements the prior inspection that's carried out at border control by inspectors who are also responsible for detecting quarantine organisms, be they fungi or any other organism. The protocol, when we have the sample in the laboratory, is official protocol of the EPPO. There are standardized protocols throughout Europe for this quarantine inspection. And firstly, we carry out the visual inspection. Secondly, isolation of the fungus. And thirdly, application of molecular methodology for diagnosis and identification. So firstly, we carry out the visual inspection, but that is actually very complicated, both for us and inspectors at the borders who look at imported fruit. It is difficult because there is a very clear symptom, which is this depressed lesion that might have pycnidia. As you can see, that's type A symptom, and that's known as hard spot. And there are other symptoms, type B, C, and D, false melanose, freckle spot, and a virulent spot, as you can see in the images here, which might also be caused by the fungus, but aren't as clear as this hard spot symptom. But these other symptoms might also be caused by other pathogens, which aren't quarantine pathogens, or by other causes such as physiological causes. So the first difficulty in inspections when you see these clear symptoms is knowing what they are. As we've heard also, infected fruits can take up to 2 months before the symptoms are visible, the specific symptoms. There's a very long period of incubation. So that's an added difficulty when carrying out inspections on citrus fruit samples. This is a photo of one of the samples we received this year in the lab. Now, it's not easy to see clear spots with pycnidia here. European legislation states that in citrus fruits, they can only be imported in fields where the fungus is not present in countries of origin, or where treatments have been applied to prevent the fungus infection. So it's usually batches should not contain fruits with advanced symptoms. If the visual inspection is not sufficient, the second step is isolation. But there's another serious problem with this fungus again, and that's what it sets out here. It's very slow growth, and it might take more than 20 days to have a 1 centimeter diameter colony. And the conidia, which may be very characteristic, these spores can be confused with other types of Philosticta species that may be present in the fruit. And even though there are cultural methods to diagnose these, it's not a very easy task. This is an image of the growth of the fungus, the isolation that we take from an affected fruit. As I've said, these are small colonies. This is a photo taken at 20 days. They're difficult to obtain also because other saprophytes that grow much more quickly grow on top or together with the colonies, which makes it difficult to analyze. And this means that some of it has been blocked at the border. We have to be waiting for 20 to 25 days to be able to release that that consignment from the border, and obviously that's very difficult with phytosanitary protection. So this is a diagnosis based on the culture media, but it's very difficult because there are other species, saprophyte species, that may be present on the fruit, for example, Philosticta capitalensis, and it's not always easy to distinguish between the two in culture medium based on just morphological characteristics. The ascospores are quite characteristic, but again, it might be hours of microscopic work to be able to distinguish Citricarpa from other Philosticta. And in these slow growth colonies, the sporulation is also much slower. And in addition to all of this, there's a new problem come up recently, which is a description of a new species, Philosticta citriaceana, which specifically affects grapefruit, large citrus fruits like that you can see here. You might ask, well, do we import this type of fruit? Well, we do, and we've had to paralyze imports not just of limes, lemons, tangerines, but also other fruits such as this one. And from time to time, we have to inspect for the possible presence of Philosticta citriaceana, a new species. Now, the reason I'm telling you about all of these issues is really to show the importance of phytosanitary inspection, both at the border and in laboratories, reference laboratories in Spain and in other European countries. Thankfully, For many of the quarantine pathogens, we now have specific methods. For example, we have real-time molecular diagnosis, PCR, which gives us diagnosis in 24 to 48 hours. We can confirm the absence or presence of the pathogen in suspected samples with high sensitivity also. So even if the symptoms aren't very clear, we find positives. As I've mentioned, you have to have equipment and you also have to have a highly skilled team. And here you can see my team from my laboratory who carry out inspection and samples of fungus in citrus fruits and other products. And also then we have all of the plant protection services and inspectors who carry out very difficult and very complicated work because they're facing the same challenges that we are in the laboratory, if not harder, because of the high number of samples that they receive in such short spaces of time. Thank you very much.